Hello and welcome back to SQA Higher Maths, applying differential calculus, looking at areas above and below the x-axis. So just another question, just to go with the previous video, just an extra question. Calculate the shaded area shown in the diagram below. So once again, we need to split this into two separate areas. So we'll need to integrate between 2 and whatever this value of x is, and then from this value to 5. How we're going to find out this value? Well, we know the equation of the parabola. If we want to find the roots, we just set this equal to 0, because at this point the y coordinate is 0, so we can say that y equals 0. And when we do that, we get two answers, obviously. We get x equals -6 and x equals 4. Now, obviously, -6 will be along here on the left-hand side somewhere, because this parabola will come back up and intercept the x-axis to the left of the diagram. So our value of x here is 4. Now once I've done that, all I need to do is to integrate this function between 2 and 4, and then integrate it again between 4 and 5. Remember, for area A here, I should be getting a negative value because it's below the x-axis. That's something to be thinking about even before we start to do any writing. So integrate, so x squared becomes x cubed over 3. 2x becomes 2x squared divided by 2, which is just x squared. Integrate 24, we get 24x. So all of that between 2 and 4. Substitute in our upper limit and our lower limits. Evaluate both brackets, and we get an area of -52/3 square units. So guys, this may be non-calculator, so remember 36 holes would be 36 lots of 3/3. So 36 threes are 108. 56 minus 108 is indeed -52, so it'll be -52/3 square units. Remember, we need our statement. We need to show whoever's looking at our work that we understand that this is because the area is below the x-axis. So negative sign indicates area below the x-axis. And then do the same between the limits of 4 and 5 to work out the area above the x-axis, which will be 16/3 square units. Again, guys, just doing exactly the same thing. Integrate it, so you should get the same thing as you got in finding area A. Substitute in 5, substitute in 4. And then find the total area. So sorry, we get 16/3 square units there, and then find the total area. So 52/3 plus 16/3 would be 68/3 square units. And that is us done. Okay, so obviously we've just done two examples on it, but I'll say it one more time. If you have an area above and an area below the x-axis, you need to split it up into two separate integrals, evaluate both of them. Remember, the area below the x-axis should have a negative value when it comes out. Once you've evaluated it, make your statement, add the two regions together to get the total area.